I'm gonna be talking about the behind the scenes behind real-time notifications. We're gonna start with basic concept about what real-time web is. Um, when you read the concept, you're gonna see something like a network web or using technologies and practices, blah blah. In other words, what this tries to accomplish is getting updates in the client side without explicitly asking for them, like not like hitting F5 multiple times to get what you want, but instead receiving the data as soon as it's published. Um, a little bit of history behind real-time web. It's been out there for quite a long time. Uh, Everything started back then with Java applet. Who didn't use Java applet, right? It's just a program that runs in the client, and it uses the Java virtual machine. And this process is running separate from the web server. Then we had Flash. Actually, we still use Flash on some sites. It still use Flash. Then we had Microsoft developed ActiveX component with the name XML. That's not me, right? No. Okay. The extension was XMLHttp, and this extension was later adapted by Mozilla, Safari, and Opera as XMLHttpRequest. It's a long name, that's why we use XHR. And then we had Comet. Comet is not just a particular approach to solve this problem, but a group of strategies on how to solve the problem of getting the real-time notifications without reloading the page. Some of the implementations that came with Comet, hidden Iframe, XHR Polling, Long Polling, and JSON-P. There are some others, but I took these ones as an example because the demo that I plan to show basically use these concepts. So let's go back to web development 101. The HTTP protocol is something as simple as we have a client that asks for something, and then the server gets what you asked for. Okay, it's more complex than this, but I want you to keep this concept in mind because the mechanism that we are going to talk about is going to involve this concept a lot. So for a hidden iframe, I personally hate iframes. But basically, what we do with a hidden iframe is that we are gonna be sending a script tag to this in hidden iframe. That script is going to contain code to be executed in the client. This code might just update like the stock of a particular product, for example. Two major flaws that we have with this approach is that the lack of a reliable way to handle errors. In fact, you will know when an error occurs, and it's impossible to track the state of the request. Another technique that we have is XHR Polling. With this technique, what we do is that we keep sending requests to the server asking for updates. Even if the server doesn't have like real data, we're gonna be hitting the server each time. So the major flaw that we can see here is that we are gonna cause a huge overload in the server. Of course, you can always throw hardware to the server, but I don't think your boss will like that solution or your client. So the XHR will work like this. We're going to be sending a request. If I don't have anything, I will just send an empty response. And we will keep repeating the same process over and over again. And just when I have the updates or the data that I need to send to the client, we don't send that immediately. We need to wait for a new request. And after we get the request, we send the data. So imagine, for example, having a CakePHP application, and then you have in the client JavaScript code that is going to be hitting the server like every second. And think about all the resources that we are wasting over there, all the stack being loaded just for nothing, because maybe we don't have the data that the client is asking for. So this problem was partially solved, actually solved, by this technique, long polling. Unlike XHR polling, the server won't respond immediately, but instead the connection will be kept open for a couple of seconds. As soon as we get the information, we might send the data back. If we don't have anything, we can just send an empty package. So it will be working like this. We send the request. The connection is not closed immediately, so you will have to modify the header to keep the connection open. If there is no data, we're gonna keep waiting, and as soon as we have the data, we're gonna send it back, and then the client will emit another request to the server. One real-world example that I wanted to bring is Facebook. If you load your Facebook profile after everything is rendered, if you open the network tab, you will see that there is going to be let me move, yes, here. There's going to be a request that is going to be in the status pending, and the reason for that is because like I said, they're using a long polling approach. They keep the connection open around 30-40 seconds. It depends. You can see that, like the request, other requests have their status like 200, but this one, no, you just stay there. If you click on that request to see the details, you will see that in the preview tab, there is nothing, because we're still waiting for something. After we get a response is when we are going to hit the server again, asking for more data, for more updates. So that's why when you see your Facebook page, it might take a couple of seconds between each update. Like, you don't see like 10 updates at the same time, unless, of course, they can send in a simple JSON object multiple updates. And yes, that one. Here I have you can see that the time it took was 50 seconds. It has a status now, and then this is the new request that was sent to the server. So as you can see, in a period of 60 seconds, we just hit the server twice. Instead of, if we were using XHR, the plain one, we will be sending like 60 requests in a second, in a minute. So it doesn't make much sense. So this is like a better approach for this. Another thing to bear in mind with this approach is the cross-domain policy. So all requests that I receive in the server side, they must belong to the same domain. So if you want to do some cross-domain request, you will have to use a different approach. For that, we have JSONP. With JSONP, we send actually the callback as a parameter to the server. So as you can see, with this approach, we are solving the problem, but there are nothing but hacks to the HTTP protocol. When the protocol was designed, these people didn't have this in mind. So that's why nowadays we have HTML5, and HTML5 brings new concepts for solving this problem. We have two techniques to solve this problem. The first one is the server event, the server send events, WebSockets. So the server send events will help us to accomplish the main objective, which is sending the update to the client without having the client asking for them explicitly. In order for us to use this approach, we have a JavaScript API where we will create a stream that is going to be used to send the data. The downside with this approach is that server send event is not available on Internet Explorer. And another thing to bear in mind is that the communication is unidirectional. So the communication is only between the server and the client. There is no way for the client to emit an event. So here's a simple example about how to use a server send event. We basically, in the client side, we create an object of this class, event source. We pass the URL. Immediately, we will set a couple of event handlers. In this example, on message is a generic event. This event is triggered as soon as the server sends something to the client. On the server side, there are a couple of things that you need to keep in mind. One of them is that you need to modify the header to be event stream, as you can see here. There is no need to catch this, and the data needs to be needs to follow this format. It needs to have the data work followed by the colon, and the end of the message is represented by two new line characters, as you can see here. You can actually create your own event. For example, from the server, I want to emit an event when a user logs in. For example, if you want to notify the user, hey, your friend, blah, 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 just sign in. So the data that we are going to send from the server needs to follow this format. If we are going to send a custom event, we're going to send the name of the event. In this case is user logon, and the data that we want to send. Again, you can send either plain text or a JSON object. What is important is to end the data with two new line characters. So on the client side, you need an event handler for that particular event. User logon. So that's why we add here, it's very simple. Add event listener, pass the name of the event that you are waiting for be triggered from the server. And then we have the callback there. So the data is going to be available here in this object. in this, well, you need to parse it, of course, because it's a JSON, and that's it. Like I said, the problem with this is that this is not available for Internet Explorer, so that's why it's not that popular. Then we have WebSockets. WebSockets, it's a more complex concept. Like a server send event, the communication here is going to be bidirectional, meaning that the events can be sent from the server to the client or from the client to the server. And the connection will be kept open all the time. So there is no request being sent to the server. How do we use it? It's really simple. We just create an object of this class, WebSocket. Notice that the URL we are passing WS because that's the protocol. It's not HTTP anymore. And we have some callbacks. Like these are like events that we have by default. On open, it as you can see is when the connection is open, or whenever there is an error, this event will be triggered. In order for us to send the data, it's really simple. You just call the send method and send the data that you want to send. You can send plain text or a JSON or even binary data. On the client side, you will have to have a handler for that event. Every time we send a message from the server, on the client side, this event will be triggered on message. It's important that you understand the dynamic that we have in WebSockets. We basically have on the server side data that we want to send to the client, and we will do that with an event. And on the client side, we need an event handler for that particular event. On the server side, you can do that with any language. There are multiple implementations for multiple languages. As for PHP, one of the most interesting libraries that I found was Ratchet. We have a couple of libraries over there. It's basically an interface where we have these methods like on open, on error, on message. Here you have the URL if you want to take a look at this library. And now I'm going to talk about how we use Node.js for real-time applications. Before I go any further, I want to ask you guys, who doesn't have any experience with Node.js? No experience. Okay, that's fine. The code that I'm going to show that doesn't require like knowing Node.js that much. Okay, who is an expert in Node.js? Okay, you're gonna be doing the Q&A then. Okay, you said that you are an expert. Okay, so why should we use Node.js? As a developer, we should be open to new ideas and new tools. For every problem, we have a different set of tools. As much as I love PHP, I like PHP, there are some limitations, and this is one of them. PHP wasn't built with this in mind. Yes, you can have your server and implement this library that I showed before, but I don't feel that is the right way to do it. In fact, when you compare the benchmark between PHP and a Node.js application, you will see that Node.js can handle like more than PHP. So one of the reasons is a non-blocking I/O API. What this means, I want to use an analogy to explain what this means. Imagine that you go to a restaurant, non-efficient restaurant, right? And you are in front of the cashier and you ask for something, and this person will send this order to the chef, and then you're gonna stand there waiting for your food, and then there are like 10 people behind you, and they cannot place your order, their order until you get your food back. So nowadays, modern restaurants, they will just tell you, move along. Here you have a token. Whenever we have your food, we will let you know when your food is ready, and we can keep attending the rest of the clients. This is basically what non-blocking I/O API means. We can keep processing multiple requests without forcing the user to wait until we have the final result. And another thing is that it's event driven. You can have multiple event handlers over there. Like I showed you in previous slides, we can have an event for when a user submits a new comment in an article, things like this. There is another cool library with the name Socket.io. Socket.io is a JavaScript library for real-time applications. It has two components. One is the server library that runs on Node.js and the client library. Both have a similar API, so it's really easy. When you see the example that I have in the next slides, you will see that it's very straightforward. Another cool feature about Socket.io is that it will use by default WebSocket, but it will determine if your browser doesn't support WebSockets. It will use Long Polling, or you can even in the client you can configure and say, okay, I want you to use always Long Polling or WebSockets. One thing that I forgot to mention is that I think that after Internet Explorer 10 is when IE started supporting WebSockets. Okay, so I have here an example. Like I said, can you read that? Yes? Okay. So on the server side here, we're gonna have this code that just creates the web server. This section just is a route. So whenever we hit this case the root, we're gonna send a file with the name index. On the right, we have the client code that we are going to send. So as you can see, the very first thing that we need is to include the library, and then we need to create the IO object, and the method that we are going to call is connect, and just pass the URL. And as soon as we connect on the server side, there's going to be an event that is going to be triggered. In this case, the event is connection. It's pretty simple. Like I said previously, the dynamic that we are going to have is that if the server emits an event, then in the client side you need a handler for that event. Likewise, on the client side, if you emit an event, on the server side, you need an event handler for that particular event. So in this case, after I connect, we're going to emit an event. As you can see, it just takes two parameters. The first one is the name of the message, and the second one is the data that you want to send back. So on the client side, we need a handler for that particular event with the name news. And as you can see, you have the data available there in the data object. Then on the client side, we can also emit an event. In this case, we are emitting an event with the name my other event. So this means that on the server side, we need a handler for that particular event. So if you want to integrate your CakePHP application or any PHP application with Node.js, the very first thing that you need to keep in mind is that after the user logs in, if you want to protect some actions, after they logged in, you need to store the session in a cache. You can use Redis, main cache, whatever you want. It's not that important. And one thing to keep in mind is that the way PHP serializes the data is a bit weird. So you will have to use a special parser for that. Fortunately, there are like a lot of libraries for this. As for the communication between PHP and Node.js, there are multiple approaches. What I did for this demo is that on the client side, as you saw, I'm going to create an IO object, and I am going to connect to the Node.js application. And as soon as something happens on PHP, for example, if somebody adds a comment on an article, I will let Node.js know that something happened on PHP. So I prepared a demo. The code is on GitHub. There are two applications, of course. The first one is the CakePHP application, and the second one is the Node.js application. Like I said, you need no previous knowledge about Node.js. Just clone it and run it. So on the CakePHP side, what I wanted to do, right? I just grabbed the blog tutorial that we have in the docs, and I just had an event listener. So every time a comment is added to an article, or every time an article is added, this event will be triggered, and we will send a request to Node.js with the data that I want to send to the client. Pretty simple. One thing that I forgot to mention about Socket.io is the fact that business notifications, even though you can send the data to all clients, you can have rooms. The same thing happens with WebSockets. You can have a particular room where all the messages will be shared between that group of users. As an example that I have, if you are reading an article and somebody adds a comment, you don't want to see comments being added to another article. You just want the comments added to that particular article. So those connections will be in a room. So this is the CakePHP code, the event listener. There is more code, of course. That's why I put the URL to my repo over there. But basically, we just have two methods one method for the articles and the other one for the comments. And we prepare the data that we want to send to the client. And both methods will call the send notification method. We are using the HTTP client library that we have in CakePHP. We will encode this as a JSON. And on the Node.js side, you need like to be an expert. It's basically almost plain English. For example, for the articles, when somebody adds an article, let me go back. The endpoint is going to be article notification over here. So that on Node.js, every time we receive a request to that particular URL, we're going to read the object that we are receiving. Remember that the entities in CakePHP have is new property. If it's true, then it means that there was a new article. And then we will have to emit an event with the name new article. So this means that in the client side, we need an event handler for the new article event. If it's not true, then it means that an article is being modified. And we will emit a different event. In this case, is updated article. The same thing goes for new comment. As you can see, I am emitting the event in that particular room. The name of the room just has the article ID as the name. On the client side, so basically we just connect to the Node.js application, and after we connect, we are just waiting for event to be sent from the server. So in the case of a new article, when we receive the new article event, we just prepare a tag, a simple div with the information that we need to show on the client side. And the same thing goes to the other two events. I think I have time to show. Right. Okay. So I have this, and I have another client here. So what I'm going to be doing is that if I open a new simple article here, and I add new, so in this browser, I keep this open so you can see that no requests are being sent to the server. And after I save, here I just received here the notification, and no request was made to the server. The same thing goes for, okay, I'm here logging the data that I'm sending. The same thing will happen if I add a new article. If I add a new article, you will not see any request on the other client. But if I were using Internet Explorer 8, for example, you will be seeing multiple requests because Socket.io will be using long polling as a fallback mechanism. So I think I have a few more minutes. If you have any questions. Yes?
Can you
I'm sorry.
Can you make the same request from the first browser on the left, log into net tab in the Firefox?
Like, okay.
I know sometimes you don't see the same request here on the console and that you see in it.
Okay, like, okay, you want me to add a comment in this, in Firefox? And
Yeah, no. From the first browser, log in the net tab in your private browser. You see the network
yes, here.
right before cookies? No, on the second browser. Left, right.
Here?
No. That's the script.
Oh, here. Okay. Okay. Okay.
You need to refresh the thing.
Right. All right. So another thing to keep in mind is that for WebSockets, is that it will not work that well if you are behind a firewall. In this case, let's see. Yeah, there are no requests being sent, but I can go back and add a comment here. This is the title. And that was it. So no request was sent. We can also, anyone has another question? Yes.
Tell us a little bit more about how rooms work.
Right. With Socket.io, as soon as you create the Socket.io object and you call the connect method, on the server side, there will be an event that is going to be triggered. That is the connection event. Let me go back to that slide. I think is okay here. Right. Okay here. So on connection, yes. Oh, time. We ran over time. Okay. Okay, I'm sorry, guys. I will go there. So not even a minute. 60 seconds. Okay, 60 seconds. So on connection event, on connection event, we receive the socket as a parameter, and then we can actually on the client side, after we connect, we will emit an event. It's not in this slide, but on GitHub, in the article view page, the JavaScript, you will see that after we connect, we emit an event with the name join room. So the client will ask, okay, I want to join this room, and you pass the name of the room. And then on the server side, we take that socket and we just join that socket to a particular room. So it's like a namespace, and everything that we send to that particular room in that namespace will be seen only by the sockets connected to that particular room. I don't know if that answers your question.
Yes, thank you.
Okay. That's it. Thank you.